Geometry in the European Middle Ages.
Welcome to the Deep Dive. Today we're heading into the European Middle Ages, looking specifically at geometry. Now, you might think of this time as maybe less focused on science.
Yeah, that's a common picture, isn't it? Knights, castles.
Exactly. But beneath the surface, there was actually some really fascinating stuff happening with geometry.
Absolutely. It's easy to think progress just stopped after the classical world, but actually the Middle Ages were, well, vital for keeping geometry alive and even developing it. Set the stage for later on.
Right. And to really get into this, we've been digging into a chapter from what looks like a medieval geometry textbook. It's dense, for sure.
Definitely dense.
But it's packed with insights. Yeah. So our mission today is to sort of unpack how geometry was understood, how it was used, and honestly, you might find some surprises about medieval thinking. Okay, so where do we start with medieval geometry? It wasn't like a clean break, was it?
No, not at all. I mean, you have to remember that after the Roman Empire, things did get a bit fragmented, let's say, in Western Europe, scientifically speaking. But crucially, the Islamic world was incredibly important. They didn't just preserve Greek maths and science, they built on it. And a lot of that knowledge eventually flowed back into Europe.
Through places like Spain, right?
Exactly. Spain, Sicily.
Yeah.
That transmission was fundamental. It really kickstarted things again in Europe.
So it wasn't starting from zero, it was more like rediscovering and building on this legacy. Yeah. Now, the source we looked at talks about the 7 liberal arts. What's that all about? How did geometry fit in?
Right. The 7 liberal arts were basically the standard curriculum for higher education. Think of it in 2 parts. You had the trivium that was grammar, rhetoric, dialectic, language, logic, argument.
Okay.
And then the quadrivium. That's where the mathematical sciences lived. Arithmetic, geometry, astronomy, and music.
Yeah.
Geometry was right there, key part of the quadrivium, seen as a science of spatial magnitudes, shapes, sizes, space itself.
It's interesting how they grouped them, that visual we saw in the text, that sort of map of knowledge.
Yeah.
Geometry was right next to astronomy.
Yeah.
Suggests they saw them as really closely linked.
Oh, definitely. Putting geometry with arithmetic, astronomy, music, it shows they saw these as connected, fundamental ways to understand how the cosmos worked, its order. And early figures like Cassiodorus back in the 6th century were key in setting this up, especially in monasteries.
Cassiodorus,
Yeah.
he wanted monks to study these classical texts, right, to preserve them.
Exactly. He defined geometry as terra dimensio, literally, earth measurement.
Earth measurement, so like surveying?
Well, yes, but his view was actually pretty broad. It included surveying, sure, but also things like the size and relationships of the Earth, even the planets and stars. His big work, The Institutiones, had bits on geometry.
Wow, that's wider than I'd expect for geometry back then. Seems it was tied to the physical world, even the heavens, right from the start, not just abstract lines.
Precisely. And then fast forward a bit, early 8th century, you have someone like Venerable Bede.
Bede, right. What was his contribution?
Well, Bede was part of that growing scientific learning, especially in places like the Irish monasteries, which were becoming quite independent. His work shows he understood things like the moon's phases, the tides.
Ah, so practical applications again. Using astronomy and the geometry behind it to understand the natural world.
Exactly. You see this trend. And later, under Charlemagne, you had figures like Alcuin pushing for education, making sure geometry was part of the curriculum in schools. Finding actual textbooks from that specific time is hard, but we know it was valued.
Okay, so it has this place in education. Practical uses are emerging. What about the core geometric ideas themselves? What texts were they actually using? It probably wasn't just pure Euclid, was it?
No, not really. Especially not early on. For a long stretch, the main go-to text seems to have been this compilation called Boethius's Geometry II. Pops up around the 11th century. We're not even totally sure who put it together.
Boethius's Geometry II, okay. And it wasn't like Euclid's Elements.
Not quite. It was much more practical, less purely theoretical. It seems to have had 2 main parts. One had sort of simplified bits from Euclid, but crucially, it also included practical ways to do calculations using an abacus.
An abacus for geometry. That's cool.
And the other part was focused on surveying. So, you see, full-blown theoretical Euclid wasn't that common in general use until later. The source even has that picture, right? Doing geometry problems with an abacus really drives home the practical angle.
It really does. Okay, now the timeline mentions scholasticism starting around, 1175. How did that whole intellectual movement play into things?
Scholasticism. Well, that was a massive shift in thinking. Huge emphasis on logic, reason, analyzing texts, really carefully, mostly in theology and philosophy at first.
Right.
But that focus on rigorous, structured argument, it influenced everything. It kind of provided the intellectual toolkit for more systematic thinking across the board.
Yeah.
In the universities, the cathedral schools, it pushed towards more analytical approach, which eventually fed into how people thought about mathematics, including geometry. Maybe not direct geometric discoveries right away, but it sharpened the tools.
So scholasticism provided the framework, the logical rigor, that could then be applied to maths. Got it. Now, a really big change seems to be the translations from Arabic. Tell us about that.
Ah, yes. This is where things get really interesting.
Yeah.
Starting around 1075, especially in places like Toledo in Spain,
Toledo, yeah.
there was this huge effort to translate major scientific and mathematical works from Arabic into Latin. This was just transformative. It brought back texts by Euclid, other Greek thinkers that had been preserved, studied, and importantly added to in the Islamic world.
Added to, so not just straight translations.
Yeah, exactly. Figures like Adelard of Bath, around 1120, he was translating Euclid's Elements. But these translations often came bundled with commentaries by brilliant Arabic scholars. These commentaries offered different proofs, new ideas, extended theorems. They massively enriched Europe's understanding of geometry.
So Europe was reconnecting with its classical roots, but through this incredibly valuable filter of Islamic scholarship and advancement. That's a key point.
It really is. It wasn't just receiving ancient texts, it was receiving them enhanced.
And the source mentioned Campanus of Novara later on.
Yes, Campanus. Before 1260, he put together his own edition of Euclid. He drew on those earlier translations and commentaries, and his version became the standard textbook for centuries. It marked a big step towards having a really comprehensive Euclidean geometry back in the mainstream in Latin.
Okay, so the theoretical side is definitely picking up steam with these translations and additions, but let's swing back to the practical side. How is geometry being used day to day? The textbook mentioned Hugo of St. Victor.
Right, Hugo of St. Victor, 12th century. He's a great example of the practical focus. He really emphasized teaching skills like surveying land and using instruments like the astrolabe.
The astrolabe, right, for measuring angles and distances. We saw diagrams of that.
Exactly. The diagrams show it clearly. He wanted his students to have real-world skills measuring fields, figuring out how tall a building was. Very hands-on stuff, quite different from just pure theory.
Makes total sense.
Yeah.
Geometry wasn't just brain exercise, it solved real problems. And then Fibonacci Leonardo of Pisa, 13th century, we know him for numbers, the sequence, but geometry too.
Yeah, we mostly think of his Liber Abaci for bringing Hindu-Arabic numerals to Europe and for algebra and arithmetic.
Which was huge.
Absolutely huge. But that book also tackled geometric problems, often linked to practical things, trade calculations, measurements. Shows geometry was still very much part of the practical mathematical toolkit.
And the link between geometry and astronomy just keeps popping up. Johannes de Sacrobosco.
Yep, Sacrobosco. His book, De Sphera Mundi, on the sphere of the world from the 13th century, was incredibly popular for ages. It was the basic astronomy text. And it relied heavily on geometry to describe the cosmos.
Like the Earth being a sphere, planets moving in circles, that kind of thing.
Exactly that. The illustrations in our source, those astronomical diagrams, they're all about using geometric shapes and ideas to map out the universe.
Seems like trying to understand the heavens was a major driver for using geometry, which leads us to trigonometry, which the source also brings up.
Precisely. Trigonometry really started developing more seriously in Europe during this time because astronomers needed it.
Yeah.
When they started translating works by Ptolemy and also Arabic astronomers like Al-Zarqali, these texts had advanced trig concepts. That spurred the creation of trig tables and techniques in Europe. You needed it for accurately calculating positions and movements in the sky.
So from the liberal arts curriculum to surveying to mapping the stars, geometry was clearly pretty important in medieval thought. Now, heading into the 14th century and later what happens then, Paris and Oxford come up as key places.
Right. By the 14th century, universities like Paris and Oxford were really buzzing intellectual centers. You had thinkers like Robert Grosseteste and Roger Bacon there.
Weren't they more focused on observation experiments?
Yes, exactly. They really pushed the importance of looking at the natural world, gathering evidence. While maybe not pure geometers themselves, that empirical approach influenced everything, including how people approach science and maths. It laid groundwork. The picture of Merton College at Oxford kind of symbolizes these hubs of learning.
And at Oxford, there's Thomas Bradwardine. He seems more theoretical.
Yes, Bradwardine got into some pretty abstract geometrical questions. thinking about infinity, continuous quantities, philosophical aspects of geometry. So you see this deepening interest in the theory alongside the practical stuff.
Okay, now shifting gears a bit, the source talks a lot about applied geometry in the High and Late Middle Ages, especially for building. This sounds fascinating.
Oh, it really is. This is where you see geometry made solid, literally. Those incredible Gothic cathedrals, they weren't just guesswork.
No way.
They relied on some seriously sophisticated practical geometry. Villard Donancourt's sketchbook from the 13th century is amazing evidence. It's full of drawings showing geometric methods for designing complex things like tracery in windows or how to lay out the vaults overhead. The illustrations we saw from his book, just incredible.
Those sketches are mind-blowing, like a medieval blueprint full of geometric tricks. And the source mentioned the Bauhut, German builders' lodges.
Yeah, the Bauhut, these were like guilds, workshops of master builders, highly skilled craftsmen, and they often kept their geometric knowledge quite secret, passed down within the lodge.
Trade secrets.
Kind of. We have these little booklets from the 15th century by guys like Matthias Roricher and Hans Schmaromer. Roricher's booklet concerning pinnacle correctitude, great title, right?
All right. Yeah.
It shows, step by step, using geometry, how to construct really complex things like the pinnacles on top of cathedrals. The diagrams are incredibly detailed. It's just amazing what they achieved, often without the kind of algebraic notation we use now.
It really makes you appreciate the power of practical know-how and how knowledge was passed down visually and through practice. Beyond buildings, did geometry play other roles? Visualization, maybe?
Yeah, that's another angle. Geometry became a tool for visualizing abstract ideas, too. Think about those diagrams, like the trees of vices and virtues.
Oh, right. We saw one of those.
They used geometric layouts, branches, connections, spatial relationships to map out complex concepts,
Right.
moral hierarchies, or theological arguments. It shows geometry being used not just to measure the world, but also to structure and represent ideas.
So it's a tool for measuring physical space and for organizing abstract thought. Interesting. And finally, the source gives some specific examples of practical problems they tackled.
Yeah, things like, how do you figure out the circumference or area of a walled town? Maybe for defense or supplies. Or using that astrolabe again for surveying, getting accurate distances, heights for building projects or mapping land. These show geometry being used to solve very concrete, real-world problems. The source even talks about different ways they tried to solve them.
Right. So wrapping this up, it's pretty clear geometry wasn't sleeping during the Middle Ages.
Not at all. It was recognized, it was studied, it was definitely used. It started in that liberal arts framework, got this huge boost from classical knowledge, preserved and advanced through Arabic scholarship, and then found all these vital practical uses, surveying, astronomy, and, I mean, you just have to look at the architecture.
Yeah, those cathedrals are standing proof. It really drives home that even if it wasn't an era of constant theoretical breakthroughs like, say, the 17th century,
Right.
they were doing crucial work, preserving knowledge, translating it, applying it. That groundwork was essential for everything that came later in maths and science.
Absolutely. It was a vital period for keeping geometry relevant, adapting it, using it in ways that mattered for their time.
This whole deep dive really shifts the perspective, doesn't it? I mean, think about it. Those medieval builders working with practical geometry, maybe without formal equations as we know them, they created structures that just take your breath away centuries later. What does that tell you about knowledge itself? How it gets passed on, used in different ways, and leaves such a lasting mark? Definitely something to ponder. Thanks for joining me for this deep dive.
If you liked this video, please like it. Please subscribe to the channel so that we can offer similar videos.